So this is our second part of this lecture, and here we want to again solve some problems using our second formula. If you revolve a plane region, I said before, if you revolved about y-axis, then your cross section will perpendicular to the y-axis, and in that case this one will be your formula, volume formula by the method of washers. Pi into y equal to c to y equal to d. The curve right one is fy, so fy square minus the curve left one is gy whole square, integrating with respect to y. So first let us try to solve example 7. It says find the volume of the solid generated when the region enclosed by the curves, by the following curves is revolved about y-axis. So let me first sketch the graph. So this is our axis notation, and the first one y equal to 1 by x, and y equal to 1 by x we know it's a curve passes through 1 1. This point is 1 1 point, and another point y equal to 1. So y equal to 1 2 is here, y equal to 2 another line, and x equal to 2 another line, this one. So enclosed by these curves is this region, x equal to 2 is here and y equal to 2 is here. Now if you revolve this region about y-axis, then the solid you will get will have empty interior here, because this region is a bit away from the y-axis. So you need to use method of washers, and the cross section you need to take perpendicular to the y-axis, and the curve right one is this one, and the curve left one is this one. So using our volume formula we can write b equal pi, y equal, what is y here? What is y? Y and x equal to 2, because this curve is y equal 1 by x. So when x equal to 2, y equal 1 half. So y equal 1 half to y equal to 2, the upper limit, and the curve right one is x equal to 2. So 2 square minus the curve left one at here is, we need to write it x equal 1 by y. So 1 by y whole square dy, and this equal pi half to 2 4 minus 1 by y square dy, and the answer will be 9 pi by 2. I left this work for you. You can try whether you can get this result or not in your apartment. And now let us try to solve the next one, example 8. It's here we have three curves. Let me first sketch the graph, and the first one is y equal to x square minus 1. So y equal to x square is a parabola which is open up, but the vertex will not at origin here. Instead the vertex will be 1 unit below. So and other line is x equal to 2. So x equal to 2 is this line, x equal to 2, and when x equal to 2, y equal 3. So these two lines will intersect as at this point 2 3. I mean this parabola this parabola will passes through 2, 3. So this point is 2, 3, and the region y equal to 0, other curve is x-axis. So this is a region, and if you revolve this region about y-axis, then you will get a solid material having empty interior, because this region is a bit away from the y-axis. So our volume formula by the method of washers will be y equal to 0 to y equal to 3, 0 to 3, and the curve right one, if you take a cross section here, the curve right one is x equal to 2, so 2 square minus the curve left one is y equal x square minus 1, but you need to write it x square equal y plus 1, so x equal root y plus 1. So x equal root y plus 1, we need to take the positive one because we are in the positive side. So y plus 1 root whole square dy. Now this equal 0 to 3, 4 minus y minus 1 dy. This equal 3 minus y, 0 to 3 dy pi, this equal pi 3y minus y square by 2, 0 to 3, so 9 minus 9 by 2, if you put the upper limit, and lower limit will make this one 0, so pi into 18 minus 9 by 2, so the answer will be 9 pi by 2. This is the answer. Now let us try to solve the next one, example 9. Here we have also two equations. The first one is y equal to x square and the second one is it's a parabola which is open up and vertex at the origin, and this one also a parabola which is open right and vertex at the origin. So let me sketch the first one, y equal to x square, and note that both of them will intersect each other at 1, 1. So first let me put 1, 1 here. So this curve, this parabola which is open up, y equal to x square, y equal x square, and the other one is x equal y square which is open right and vertex at the origin, but this one also passes through 1, 1. This is our intersection point. This one is x equal y square, but we need to write this one like x equal plus minus y, but here it will be plus root y. So we need to revolve this region about y-axis. Then we will get a solid material having empty interior. So we need to use method of washers. Therefore v equal pi, y start at 0 and end at 1, 0 to 1. And if you take a cross section, the curve right one is this one, which is root y. So root y square minus the curve left one is this one, which is y square dy. So this equal pi 0 to 1 y minus y to the power 4 dy. And this one integration of y square by 2, integration of y4, y5 by 5, 0 to 1 pi. So if you put upper limit, you will get 1/2 minus 1/5, and lower limit will make this one 0. So forget about lower limit. And the LCM here is 10, 5 minus 2. So this equal 3, 5 by 10. So let me first calculate the point of intersection of these two curves. So y square equal to y plus 2, y square minus y minus 2 equals 0. This implies y square minus 2y plus y minus 2 equals 0. This implies y minus 2 plus 1 into y minus 2 equals 0. So y equal minus 1 and 2 and x equal 1, 4. X equal 1, 4. So the first intersection point will be 1 minus 1. It means this one. And the second one 2, 4. Sorry, 4, 2. 1, 2, 3, 4, 1, 2. So this is our second intersection point, 4, 2. So the curve y equal to x square will be like this. Will passes through this point. And the curve y equal to x equal to y plus 2 is nothing but y equal to x minus 2. So it will passes these 2, 3 points. So it will be a straight line. It will be like this. X equal y plus 2 and this one x equal to y square. So this is our region. Now if you revolve this region about y-axis, you will get a solid material with empty interior. So our formula will be the Wasser's method formula integrating with respect to y. So this is our formula, and y at this point is minus 1, y at this point is 2. So minus 1 to 2. And the curve, if you take a cross section like this, then the curve in the right one is y plus 2. Y plus 2 whole square minus the curve in the left one is y square whole square dy. So now you can easily integrate it. First you need to simplify y square plus 4y plus 4 minus y to the power 4 minus 1 to 2 dy. So you can easily integrate it, which will be y3 by 3 plus 4 y square by 2 plus 4y minus y to the power 5 by 5 minus 1 to 2. And I left this work for you. You can easily simplify it. First you need to put the upper limit minus you need to put the lower limit. So the final answer will be 72 pi by 5. This is the answer. So now let us try to the other example, example 11. And here we have two equations, three equations, and the limit for y is y equal to minus 1 to 1. So let me first sketch the graph. This is our x-axis, this one is our y-axis. And the first one is x equal 1 minus y square. We know x equal 1 minus y square is a parabola which is open left and vertex at 0, but here vertex will be at 1. So this one will be our graph which is x equal 1 minus y square, and the other one x equal to y square plus 2, so which is open right but vertex will be at 2. So 2 is here. So this one is the second graph which is x equal 2 plus y square. since we know x equal y square is a parabola which is open right vertex at the origin, but here vertex at 2, because you need to add 2, and y equal to negative 1, y equal to 1, let's say this one, and y equal to positive 1 is this line. So this is our line y equal to negative 1, and this is y equal to 1, and the region is this region, and if you revolve this region about y-axis, you will get a solid material with empty interior. So we need to use method of washers, and the formula is y equal to minus 1 to 1. The curve, if you take a cross section here, the curved right one is this one. So 2 plus y square whole square minus left one is this one, which is 1 minus y square whole square dy. So I think you can also simplify this one in your apartment. Let me first show you something. 2 plus y square whole square will be 4 plus 4y square plus y to the power 4 minus 1 minus 2y square. So it will be 1 plus 2y square plus y4. It will be minus y4 dy. It should be dy. So from here we can write minus 1 to 1, y to the power 4 and y to the power 4 will cancel. So we have 3 plus 6y square dy. If you take 3 out of integration, you have 3 pi minus 1 to 1, 1 plus 2y square dy. So this equal 3 pi integration of 1 y plus 2y 3 by 3, y to the power 3 by 3 minus 1 to 1. This equal 3 pi. If you put 1, you will get 1 plus 2 by 3 minus, if you put negative 1, you will get negative 1 minus negative 2 by 3. 3 pi 2 plus 4 by 3, which is equal 3 pi 3 6 plus 4, this equal 10 pi. So 10 pi is the volume. So let us try to understand our last example in this lecture, and in this topic, method of washers. So this example is a bit different what we discussed before. You see, revolving around a line, the region bounded by given curves, if you revolve around a line that is not an axis, then how can we deal these types of problem? And you see, let me first sketch the graph. Find the volume of the solid generated when the region under this curve y equal to x square. So we know y equal to x square is a parabola which is open up and vertex at the origin. This is our y-axis. This is y equal to x square over the interval 0 to 2. 0, 1, let's say 2 here, 1, 2. So if you revolve this region from 0 to 2 about a line which is not x-axis instead, and we know x-axis means y equal to 0, but we need to revolve this region about y equal to negative 1. We are revolving about this line y equal to negative 1. So if you revolve this region about this line, then you will get an empty interior like this. You will get an empty interior like this. This is your empty interior, and the solid will look like this. So this is the solid part. And now, since you are revolving about a line which is parallel to x-axis, your cross section will perpendicular to the x-axis. You see, if you take a cross section here, this one will perpendicular to the x-axis. So the question is, what is the radius? What is the radius? The first radius, and this is the second radius. You need to subtract this part. So the second radius is 1. Easily we can understand that the empty region has radius 1, but the whole solid has radius this. And we know this means fx, this one means fx, and you need to add another one to get the radius of the whole solid material. So the volume will be pi times x equal to a to x equal to b fx square minus gx square dx. By using this formula, we can write the lower limit of x 0 and upper limit 2. So 0 to 2, and fx is nothing but y plus 1. Fx here, the radius of the whole solid including empty interior is fx plus 1. So fx plus 1 means x square plus 1. So x square plus 1 whole square minus gx. Easily we can understand that gx equal to 1. So 1 dx. So that's it. It's not so difficult, but you need to note that in all cases we just take fx, but here you need to add another 1 with the fx. So if you simplify it, you will get x4 plus 2x square plus 1 minus 1, 0 to 2 pi dx. So 1 and 1 will cancel. Integration of x4, x5 by 5 plus 2 x3 by 3, 0 to 2 pi. So this equal 5 times, if you put 2 here, 2 to the power 5 equal 32 divided by 5 plus 2 cube 8 times 2, 16 by 3, and if you put 0, it will be 0. So this equal pi times 15 is the LCM, and 3 times 32, 96 plus 80, which is equal pi times 176 divided by 15. So we can write 176 pi divided by 15. So this is the answer. So that's the end of this lecture, and hope to see you in the next lecture. Thank you very much.